In this question, we are given a VT curve as shown, and we need to find out the pressure of the gas at X point, at Y point, and Z point. 1 mole of gas is undergoing this cyclic process. Now for this question, let us first define the pathways. Now if you take XY path, we find that volume is remaining constant. So if the volume is constant, it has to be an isochoric process. For XZ path or ZX path, we find that the temperature is constant, T is constant here, therefore it has to be an isothermal process. For YZ, we find the volume versus temperature curve is a straight line. Now if volume versus temperature curve is straight line, then pressure has to be constant, because volume is equal to Nr T upon P. This is equal to slope V versus T, and if slope is constant, then only we will get a straight line curve, and for a constant slope P has to be constant. So YZ has to be an isobaric process. Now let us first calculate pressure at X. We are given the number of moles, temperature at X is 200 Kelvin and volume is 50 liters. So we have calculated, comes out to be 0.328 atms. Now for Y, we know that this is an isochoric process, therefore the ratio of pressure into temperature for X and Y will be same. Px upon Tx is equal to Py upon Ty, or we can write Py is equal to this thing, which comes out to be 0.82 atm. Similarly, for ZX process, it's an isothermal process, and therefore product of pressure into volume at X and Z has to be same. So Px into Vx is equal to Pz into Vz, and Pz by similar calculations will give us 0.82 atm. Therefore the answer will be A.